This section is on limits, okay? And limits are a part of calculus, so this is kind of like the calculus part of pre-calculus. All right. Now, before we get into those, let's do a little review of discontinuities. Okay. Now, these were the three types of discontinuities. Remember, this type was called a whole. This type was called an infinite discontinuity because there's an asymptote there. And then the last one over here is called a jump discontinuity. Okay. And then one other thing about discontinuities, it's removable if it has no breaks or gaps in its graph. That is, can we draw it without lifting our pencil? Okay. Well, can we finish the graph without lifting our pencil? Well, for the whole discontinuity, we can. We don't have to lift our pencil to get from one side of the discontinuity to the other. That makes it removable. Okay. The infinite, I cannot do that. I have to lift it up, put it over here, and finish the function. That makes it non-removable. Also for the jump. All right, I have to lift my pencil, so this is a non-removable discontinuity as well. All right. Okay, now about limits. Some definitions. A one-sided limit is the y value that the function approaches from either the left or the right side of a given x value. Okay, so it can approach from the left and have a one-sided limit, or it can approach from the right and have a one-sided limit. And those might be different values, as we will see. Now, okay, so that statement, that's one you want to focus on. Now, a limit is just the y value that a function approaches at a given x value if the left side limit is equal to the right side. That is, if they approach the same value, then it has a limit. Okay? All right, examples to follow. But before we do that, I got to introduce some notation. All right? Some notation. Now, this weird looking notation reads as the limit of f of x as x approaches 1. That arrow indicates it's the value of x is approaching 1. Okay, so the limit of f of x as x approaches 1. That's the shorthand notation for that statement. Okay, let's do an example. Let's look at the limit of f of x as x approaches negative 3. X being negative, x is negative 3 right here. Okay, so we're going to approach negative 3 from the left-hand side. All right, and now we're going to approach from the right-hand side. Note that either from the left or the right, both go to the same value. That place right here, and the value of the function there is 4. So the limit as f of x, the limit of f of x as x approaches negative 3 is 4. Okay. Now, note also that the function has a value of 4 at x equals negative 3. Now let's do this example. Now note this graph differs from the previous one in that there's a hole at x equals negative 3. Okay. All right. Now what we're going to do is approach once again x equals negative 3 from the left, and we're going to approach it from the right. Okay, now even though the function does not have a value at x equals negative 3, it still approaches the same value from the left and to the right. It approaches a value once again of 4. Okay, so now this is where you got to get things about the limit. It approaches a value of 4, so the limit is 4. Even though the actual value of the function does not exist, the limit still does. Okay, because it approaches a value of 4 from either side. All right, now let's do this example. Now this differs from there because now the function does have a value at x equals negative 3. Okay, but once again, we're talking about the limit. So approach negative 3 from the left, approach negative 3 from the right, and it still approaches the same value, even though the function does have a value at x equals negative 3. Okay, the value of the function there is negative 2, right? But the limit is still 4 because it approaches that value from the left and to the right. All right? Okay, now we have a jump discontinuity here, right? So the limit of f of x as x approaches negative 3. Approach it from the left, approach it from the right. Now this time they do not approach the same value Coming from the left, it approaches 4. Coming from the right, it approaches -2. Those are not the same. So the limit does not exist. All right, the limit does not exist. However, the one-sided limit does. Okay, so now this notation, note it's the same as this with one exception. There's a little minus sign after the -3. What that means is we're talking about the limit as x approaches -3 from the negative side or from the left. Okay, for the negative side of the value we're approaching, from the left, it's actually approaching a value of 4. All right, now let's talk about this. This is the limit as x approaches -3 from the positive side or from the right. So as we approach from the right, all right, the limit as we approach from the right is -2. So even though the limit does not exist, the one-sided limit does. Okay, and the way to differentiate between that is look for that little negative sign, which indicates you're approaching from the left, or the positive sign, which means you're approaching from the right. If there's no sign at all, that means we're looking for the limit, which means it has to approach the same value from either side. All right, now let's do this example. We're given this graph, and let's see. The limit of f of x as x approaches -2 from the left. All right, there's x equals -2. We're approaching from the negative side, from the left, and it approaches a value of 1. Okay, what about this one? Now we're approaching the -2 from the positive side. So we're approaching -2 from the right. So the value of the function as I approach -2 from the right, the one-sided limit is there, and that is -2. All right, now, limit of x as x approaches -2. Now, this is not a one-sided limit. This is just a limit. So it has to approach the same value from either side, and it does not. It goes to 1 here, it goes to -2 there. So that means the limit does not exist. Okay, next. The limit of f of x as x approaches 1. All right, x approaches 1 is right here. All right, coming from the left, coming from the right, it approaches the same value. All right, the value of +1. Okay, so that limit does exist. It approaches the same value from the left side and the right side. What about the limit of f of x as x approaches 0? All right, here's x equals 0. It's on the axis. And it approaches -2 from the left side. It approaches -2 from the right side. So that's relatively straightforward. That's -2. Okay. Now, what about f of 1? The value of the function at 1 is right here, -2. And what about f of -2? F of -2, well, let's see, that's an open circle. So the value of the function at -2 is right here, and that is 1. Okay. All right. I'm going to have you pause the graph now and come up with some answers to these, and I'll go over it. So what about this one? Is this true or false? Pause and come back when you have an answer. All right, we're approaching -1 from the positive side, which will lead us right there. That's 1. It says it's 1, so that statement is true. All right. What about this one? Pause. Okay, the limit as x approaches 2. All right, that's not a one-sided limit. That's just a limit. So I got to get to the same value. From the left, it goes there. From the right, it goes there. It approaches the same value, and the value is 2. And so that makes that statement true. Okay, what about this one? Pause. All right, now let's see. We're approaching 1 from the negative side. So we're approaching 1. There's 1. We're approaching it from the negative side, and it approaches a value of 1. And that makes that statement true. Pause. Okay, now we're approaching 1 from the positive side. So there's 1 from the positive side. We're approaching it, and we get to a value of 2. Ah, so that makes that statement true as well. Pause. All right, now this is not a one-sided limit. It's a regular limit, if you will. And so it has to approach the same value from both sides. So from the left, it approaches there. From the right, it approaches there. Those are not the same value. So this function does not exist. And so that statement is true. Pause. All right, now that's saying that the limit of f of x as x approaches 0 from the left-hand side is the same as if it approaches 0 from the right-hand side. Okay, so if it approaches 0 from the left-hand side, there's 0. As it approaches 0 from the left-hand side, the value is 0. Approaching 0 from the right-hand side, the value is also 0. So we get the same value, so that makes this statement true. All right, one more. Pause. Okay, let's see. This has to go to the same side because this is not a one-side limit, so it has to go to the same value from the left and the right. X equals 2 is right there. Okay, the limit of x is equal to 0. Well, approaching from the left and the right, we get to the same value. So, and that value would be 2. So this limit does exist. Okay, so that makes this statement false. All right, so that's just some things about limits, all right, that you need to be familiar with when you get to calculus class. So time to do some practice problems.